Dear students, welcome and thank you for tuning in to this video with me, Dr. Loay Al-Zube. I'm going to start a lecture today from statics and dynamics, which is a continuation of the kinematics of particle lectures that we started in chapter 12 of the textbook. In this lecture, we are going to learn how to describe the motion of a particle traveling along a curved path. Also, we're going to learn how to relate kinematics quantities, which are position, velocities, and acceleration, in terms of the rectangular component of a vector or vectors. It's a very important lecture in which we are going to expand our knowledge of kinematics from rectilinear movement into curved movement, or particles that moves in a curved path. So let's begin with the introduction. The applications of such analysis is that if you're looking to the path of motion of a plane, it can be tracked with radar actually as its x, y, and z coordinates. So we can say that we have a reference point, let's say in this position, and I have the location of this plane as x, y, and z in three-dimensional space. So this is relative again to a reference point. That's how radars actually work, and we record this as a function of time. So you will find that your x is a function of time, and y is a function of time, and z is a function of time, because the location keep changing from one point to another point. So that's very important. So it's very important to look at how can we relate these position components to the movement of a particle that moves in a curved line, on a curved line. The other question will be, how can you determine the velocities and acceleration of the plane at any instant of time? Since we have x of t, can we find x dot of t, which is the first derivative of t, that's acceleration, and x double dot of t, that's velocity, x dot, which is the derivative actually, and x double dot is the second derivative of the position, which is the acceleration. So we're going to learn how to identify these, and we're going to solve some examples on doing this. Another application to keep in mind is that as an engineer, we will be designing a lot of structures. One of those structures is a roller coaster, and you will look at a car traveling down a fixed path at a constant speed. So what is the importance of that? If a particle is moving actually on a curved path, we're going to look at the position for that particle or that structure. And again, we are assuming that all our structures that we are analyzing, we are looking at them from very low, far away distance. That's why we are assuming them and approximating them to be particles. So we would like to look at the position of that, car that is moving on the roller coaster. So you need to find, the location of that car. So you need to find x, y, and z, and those they change with time. And also you need to find from a reference point, you need to identify a vector r. So that's r of t. We would like to identify it. And after doing this, you would like to be able to identify the velocity and acceleration. Let me change the color quickly. So pink color. So let's do it red. So what I want from you guys to be able to identify is, the first thing is this is the origin of our coordinate. We need to identify a vector, that's r of t, and also we need to identify a velocity, right, vector, and the velocity is going to be v of t, right, and it should be tangential to the path. And also we need to identify an acceleration vector, a of t. So all of these are very important for us to identify, and that's why we're learning how to analyze particle moving on a curved path. How can we find the position and acceleration at an instance? This is what I meant, and we're going to show you how to do that. And if you are designing the track, it is very important to be able to predict the acceleration of the car, because the acceleration is a vector that's going to be pulling the car away from the path, and we need to make sure that this pulling force is not going to get the car off the path and create, cause an accident. So I hope that this is a quick introduction about what is the challenge and why we want to learn how to analyze a particle moving on a curved path. Thank you. Until the next video. Bye.